Hey Science 9 class, we're going to continue on with talking about electricity and static electricity. So this is our second lesson of static electricity. This is a little bit of a refresher from last time, and we talked about the law of electrical charge and talking about electrical force. So an electrical force is a push or pull between charged objects. And the law of electrical charge states that opposite charges attract and charge plus neutral attracts and like charges repel. So we talked about this a little bit last time, and we can see kind of a visual here. If we have two positives, they're going to be pushing away, and two negatives will be pushing away, and a positive and negative will attract from each other. And I also wrote from last time's lesson, a positive plus a neutral will attract, and a negative plus a neutral will attract. So what I didn't explain is, why is a neutral object attracted to a charged object? So we're going to go through that today. So a negative object will repel. So I have kind of some notes here. It says a negative object will repel all the electrons away from a neutral object and be attracted to the positive ones. So let's imagine we have a balloon. And let's imagine that that balloon was charged and it is now negatively charged. So it has lots of negatives. So I'm going to just draw a whole bunch of little negative symbols right there. And this is why a balloon will stick to a wall. A wall will be a neutral object. So let's draw a picture of a wall. So this is, imagine you take a balloon like this one right here. You charge it by rubbing it on your head. And we have a wall that is neutral. So it has plus, negative, so it has equal number of positives and negatives. Now, as you move this balloon closer to the wall, something is going to happen. And what that is going to do is, so let's take this balloon, we'll draw it again. It's still all negative. And here's our wall, like this. So the negative, it says the negative object will repel all the negative charges. So what that means is that when you bring that close, these negatives will, and this negative right here will get pushed away, and these negatives will be pushed away right here. So all these negatives will get pushed away. All these negatives will get pushed away, and all of the positives will start to attract. So the positives are going to start to move towards it right here. So there's positives are going to start to move towards it. So what we're left with then is that since these negatives are right here, all the negative charges get pushed away and all the negative charges go deep into the wall, and all the positive protons are going to be attracted to it right like this. And so what happens inside the wall, technically this wall is still neutral, but what happens is that we now have charge separation. So now that we have charge separation, it's still neutral, but we have charge separation, and that is why that negative balloon is attracted and sticks to the wall, because all the protons and all the positives are next to the wall and all the negatives are kind of further deeper into the wall. And the same thing if we had like another object, like say if we took a balloon and we charged it with something else and it is now positively charged, and we have a wall, and that wall is neutrally charged. Okay. Same thing, all these positives and positives, the positives will repel because the like charges repel. So these things are going to be pushed away, and all of the negative charges are going to be attracted, so they're going to move towards it. So these are only going to move towards it. Now, what's going to happen is that that balloon is, which is still positively charged, is all going to be right like this, and all those positive charges are going to be further away. And that's what is going to be attracting it. And so this wall is still neutrally charged, but the reason why charged objects attract to neutrally charged is because that neutral object will undergo something like this charge separation where the positives and negatives will kind of move. Now, in the next words that we're going to be going through is conduction and induction. So conduction is the direct contact between a charged object and a neutral object that results in making that neutral object also charged. So again, say if we have like a neutral object right here, okay, so this happens often if you're in your house, you're wearing some socks, and you open up your door handle to your house. So here's our door handle. Oops. So there's our door handle. Now our door handle is neutrally charged, let's say. So let's say there's some negatives, there's some positives, negatives, and positives right there. Okay, and then negative and positive. Now, if you are walking up towards this thing right here, and you are walking on the carpet and you develop a negative charge, this is neutral. These negative charges will, when you touch the door handle, will jump, and they will jump in there, and sometimes, often, you'll see an actual kind of like a little bit of a mini bolt of lightning that jumps from your fingers to the door handle or another person if you're touching them, and you'll see that, and that is conduction. These negatives will jump over here, and the result is it makes this now a negatively charged object. And that is what is called conduction. Now, the difference is from induction is when you create charge separation. And when that happens, it's more like if you are a negatively charged object and you see another object that is neutral, so it has positive and negatives, okay? And when you get near it, you get that charge separation. So in other words, all the negatives, if you're negative, all the negatives move away, and all the positives move towards. And you can kind of like feel like a little bit of a electrical tingle in the air, and that is just because it's through induction. And we're going to talk a bit more about that. But the big thing that I want you to take away from this is conduction is when you transfer some of these charges into an object, and induction is when you cause charge separation. So the previous example where I said about that balloon on that wall causing that charge separation, that would be an example of induction. Even though there's like direct contact there, those electrons are not transferring or not conducting over, so therefore it's not conduction, it's causing charge separation, and that's induction. Now, the next one right here is something that can help you with induction and conduction is a device called an electroscope. And if we're back in the school, we have enough electroscopes for each person to kind of play around with the idea of conduction and induction. So here's a picture of an electroscope, and what it is, it's this kind of glass jar right here. So you have your glass jar, and this glass jar doesn't conduct any electricity. You have a metal wire that comes through the glass jar, and attached to it is a piece of folded aluminum foil that hangs over it. It can be a lot of different things, but it's a piece of kind of aluminum foil that hangs over it. So I know I'm just kind of outlining this stuff, but it's imagine you have just one strip of aluminum foil, and then you just bent it in half, and so that it kind of just hangs over it like that. Okay, so that this is what that kind of looks like right here, and then we have like kind of a metal ball or something like that on top. Now, what is going to happen is that, let's imagine that this device right here is an electroscope. And let's imagine this device right now is going to be neutrally charged, so that there's positives and there's also negatives. And there's some positives and negatives and positives and negatives, positives and negatives. And down here, at this very important part, there's some positives and negatives, and there's some positives and negatives. Okay? Now, let's imagine that you have a charged object. So let's imagine we have that balloon again. And that this object right here is negative. Okay? And we bring it nice and close to this metal ball that's on top. So what's going to happen? I'm just going to erase this so that we can clearly see. What's going to happen when this thing comes close and this whole object is neutrally charged all through the wire? Remember, nothing can go through this cork or this glass because they're insulators. When you bring this nice and close, induction is going to occur. So charge separation is going to occur, and all the positives are going to go towards the top. Okay, because all these positives are attracted to all these negatives. And at the bottom, all the negatives are going to be right here. Now, at the important part is down here, these are also going to be negatives. Okay, so all the positives move towards the top to be attracted to the balloon, and all the negatives move towards the bottom because they are being repelled by the balloon. Now, here we have this aluminum foil, and they're all negatives. Okay, so since these negatives are repelled by the balloon, these two sides of this aluminum foil, which is bent in half, are also repelled by each other, and what will happen is that these will then move apart. So as you bring this balloon close, you'll actually see these aluminum foil little legs move apart. And that is induction. Now, if you were to touch this balloon to this object, then this whole thing would be negative, and then these little legs would just stick straight out because they would be all negative, and it will they will be permanently kind of repelling each other until until the charge can be lost and becomes neutral again. But in induction, if you bring it close, these legs will kind of spread apart, and then if you move the balloon away, they'll kind of go back to normal. And so you can kind of do some interesting experiments with those. And normally we would do that in class, and it's kind of interesting. But right now you can try doing this at home. I have a Bill Nye video clip that you can watch that kind of shows how you can make a at-home version of an electroscope, and you can watch him do some of these experiments as well. So we're going to take a quick look at this Bill Nye electroscope video, and if you want, you can try doing it yourself as well.
You can make your own precision static electricity detector called an electroscope. Yeah, all you need is a peanut butter jar. Of course, it's got to be empty, like this one. Then you need a coat hanger. And you may want to get an adult to help you with this part, but cut the coat hanger in two places like this.
Watch yourself, sir.
And now we want this piece of coat hanger to go through a hole in a peanut butter jar lid. Now, a great way to do this is with a pair of pliers and a candle. You definitely want an adult to help you with this part. After it's warm, push the coat hanger through the peanut butter jar lid. Oh, look at that. Oh, look at that. Now that right there, that is a great hole in a peanut butter jar lid for a coat hanger right there. That is a great coat hanger. Now, this piece of aluminum foil, cut it with scissors. Use your fingernail and smooth it out. Fold the piece of aluminum foil over the hook part of the coat hanger. Now screw the jar back together. Secure the coat hanger with a little piece of clay.
How long is this going to go on, Bo?
Now we need an electrode ball. You can use a piece of aluminum foil. Roll it into a ball and stick it on top of the coat hanger. Now you need some static electricity.
You're good at that. You're a little too good at that, Bill.
Look. The leaves of aluminum foil push apart. The leaves of foil are moving and I'm not even touching it. So? I think it's pretty cool. It is cool. It's an electroscope right here in a peanut butter jar.
What can you do with a jelly jar?